I use these steps to discover interesting things about recording with my equipment in my non-studio home environment. These steps will produce a spreadsheet like the one you see here, where we can drill down into the details of why some noise floor results are louder than others. Each row is a noise floor test. You can sort from quietest to loudest and drill into the loud results to understand what's causing problems in your environment. Over time, you can build a collection of test results like these, which you can reference as you try various arrangements over time. The net result is you will learn much about noise-related nuances relating to your unique equipment and environment. Alright, let's get started. All recordings will use the Zoom F6 32-bit float record mode with a 150 ohm dummy load connected to mic level input number 6. The 150 ohm dummy load replaces a real microphone so that we can capture non-microphone noise for analysis. All recordings will use a knob rec level setting of 0 dB. Let's start by capturing 3 recordings in a clear desk area away from electronics. And we'll start by using the battery as a power supply. And now let's switch to a USB wall power supply and capture a recording. And then we'll use the desktop USB hub as a power supply. Alright, let's move the recorder near typical desktop monitor electronics and capture 3 more recordings. We'll start with a recording using the battery. Next, we'll capture a recording using the USB wall power supply. And then a recording using the desktop USB hub as a power supply. Next, let's record next to an AC wall expander that we use here in the home. Let's record using battery. Next, let's record using the USB wall power supply. And since the desktop is far away from this location, we're going to skip the hub power supply test here. Let's go back to the desktop area and power on the computer and capture the same 3 recordings. Let's get 2 recordings using USB power, one with the power supply and the other with the USB hub. And let's get one with the battery as a power supply. I'll create a folder named Noise Floor Samples for the test recordings. I'll insert the recorder into the USB to access its storage and drag the files into the test results folder. The Zoom F6 places each recording in its own folder. To move them to the same folder, I'll search for star.wav, select all, Control X to cut for a move, go back up to Noise Floor Samples, Control V to paste, and move. Great, now that all the folders are empty, I'll just delete them. Awesome, all recordings are in a single folder. Now I'll name each recording using information from the notes that I took as I was capturing each recording. This includes the location of the recording, what power supply was used, and so on. Along the way, I'll delete any recordings where my notes indicate it was rejected. Alright, great. We have 11 recordings ready for analysis. I'll right-click in File Explorer and open a terminal window where the recordings are located. Let me make sure Python is installed. Great, it's installed. I'll create a Python virtual environment, or venv, named venv-nfwork. This venv will be for the analysis tools. Next, I'll activate the environment by using the activate ps1 script, which was created when the environment was created. Next, I'll install audioutil by typing in pip space install space at-audioutil-pkg, and I'll press enter. If ffmpeg is not already installed, I'll install it using winget install guyan.ffmpeg. This step varies depending on your operating system. I'll type audioutil-h to verify that audioutil is installed. Next, I'll run audioutil stats start at equals 2, stop at equals -2, /star.wav, -c for CSV, -o for the output file, which will be temp.csv. This will dump stats of all test recordings to a CSV file. We'll use this first pass to discover the quietest recording. I'll type temp.csv tab to have Windows autocomplete, and I'll press enter. Windows will start Excel and load the CSV. If I'm prompted, I'll click convert. Next, I'll select all and double-click a column separator to auto-resize the columns. Next, I'll click data, sort, select DBFS RMS, and click OK. I'll click the first DBFS RMS value, which is the quietest recording. I'll move the cursor all the way to the right to find the file's name. I'll click in the file name cell, Control-A to select all, Control-C to copy. I'll tab to the terminal window and paste the file name there as a comment so that I can reference it. And I'll close Excel. In the terminal, I'll recall the stats command and I'll add -H so that we can see the help text. We'll be using the quietest recording to specify the noise floor basis using these NF switches. Let me recall the quietest file name. Let me recall the stats command. I'll remove the -H and add --NF-path space, then copy paste the quietest recording name as the NF path. I'll press tab to confirm PowerShell inserts the // before the file name. This tells me PowerShell recognizes it as a file. Great. I'll add --NF start equals 2 and --NF stop equals -2, and I'll press enter. Great, we have a CSV using our quietest recording as the noise floor basis. I'll type temp CSV tab and enter to load the CSV into Excel. If prompted, I'll click convert. I'll select all and double click a column separator to auto resize all the columns. We don't need these columns, so I'll select them, right click, and choose hide. And I'll do the same for these columns as well. Select, right-click, and choose Hide. I'll click Data, Sort. I'll select Sort by DBFS RMS, and click OK. I'll confirm the first row is our quietest recording by observing the SNR DB column contains neg_NF. This is a noise-to-noise ratio of -infinity because it compared itself to itself. Oh, and let's hide these two columns as well. I'll select the RMS samples column, click Home, choose Scientific, and adjust to 5 decimal places. I'll select both the DBFS RMS and SNR DB columns, choose Number, and adjust to 3 decimal places. I'll select the SNR DB column and right justify. I'll right-click the sample rate column and choose Insert to insert a column. I'll repeat this to insert a second column. I'll name these two columns DBFS Delta Min and DBFS Delta Prev. The first row of these two new columns will be 0. I observe DBFS RMS is column L, so in row 2 for DBFS Delta Min, I'll enter a formula equals sum L3 minus L $2. The $sign causes the first row to be subtracted from the current row's DBFS RMS value. I'll press enter, click on the cell, double-click the lower right corner of the cell to cause the formula to be replicated. Great. For DBFS Delta Prev, I'll enter a slightly different formula, equals sum L3 minus L2, which will subtract the previous row from the current row. I'll press enter, select the cell, double-click the lower right corner to replicate the formula. Awesome! DBFS Delta Min is the dB difference from the current row to the quietest recording. It will increase for each row from the top on down. DBFS Delta Prev is the dB difference from the current to the previous row. We can use these columns to see where big changes occur. Goodness, the last two rows exhibit a big change compared to the other rows. This is surprising because that was the clear desk area, away from electronics. I expected it to be the quietest. The battery recording did best, but was still impacted by something. Both USB-powered recordings suffered from something. Let's dig into this. I'll start up Audacity, or you can use your favorite DAW. Let's drag the loudest or worst noise floor recording into Audacity. I'll select the track, click Effect, Volume and Compression, Normalize, and I'll click Apply. I'll click Play. Wow, there's some sort of EMI causing repeating ticking. I'll click Edit and Undo to undo the normalization. Now I'll click Effect, Volume and Compression, Amplify, and I'll click Apply. I'll repeat this until the amplification dB is no longer the maximum of 50. For this file, it was 3 times. I do this to control amplification and make note of the total dB increase. Notice it was 50 dB, and the last one was 14.072 dB, a total of a 114.072 dB increase. I'll make a note of this, and I'm doing this as a little side calculation to sanity check everything. Let's compare this to the quietest recording, which is test number 12. Let me drag test recording 12 into Audacity. I'll use Effect, Amplify and Compression, and amplify several times again, making note of the increase each time. 50 dB for the first time, 50 dB for the second time, 17.383 dB for the last time. A total of a 117.383 dB increase, which is a 3.331 dB difference, indicating the quietest recording has a peak sample that is about 3.331 dB quieter than the loudest file's peak sample. I'll solo the amplified quietest recording and play it. A fairly clean, snowy white sound. Nice. Let's solo the loudest recording again. Wow, that's a difference. Interestingly, recording number 1, the clear desk battery recording, seems less impacted. Let's drag it into Audacity and have a listen. Again, I'll amplify until the peak is at max before clipping. This takes 3 amplifications, a total amplification of 116.984 dB. Let's solo it. The ticking is still there, but it's more faint. Very interesting that the recordings in the clear desk area that were powered by USB somehow were impacted by this ticking more so than the other recordings. Interesting that the clear desk battery recording was impacted less than the USB powered recordings. Why was the desktop electronics so quiet while that clear desk area was clearly not optimum, at least for the USB powered recordings? It turns out the clear desk area has no obstructions between it and a powerful Wi-Fi router, while the desktop is somewhat shielded by a very thick shelf that obstructs it from that same router, despite actually being closer to it. Given these findings, I'll avoid staging the recorder on that clear desk area. I find it interesting that USB as a power source increased the effect of the EMI from the Wi-Fi router compared to the recording in the same area using battery as a power source. From this and other tests, I have generally noticed the Zoom F6 has the best noise floor on battery, where USB power, especially a hub, seems to increase the chances of a louder noise floor. Now, this relates to my particular environment and the hubs and power supplies that I'm using. I have learned numerous things by performing various tests in different locations using different arrangements of equipment and power sources. So there you go. You have what's needed to dive in and learn more about how your environment affects your equipment's noise floor. To learn more about audioutil and see a more detailed walkthrough, check out the link in the description. And don't forget to click the like button and subscribe. Subscribing is totally free and you'll get notifications from the channel when updates are posted. All right, everybody, take care. Happy noise floor hunting and may your noise floor be with you.